Hi everybody, in this video we are going to talk about some trigonometric identities. An identity is just something which is true no matter what number we choose. So for example, a very simple identity would be x plus 0 is equal to x. No matter what number I choose for x, this statement is true. So for example, if I choose the number 3, 3 plus 0 is equal to 3. So that's true. If I choose the number negative 7.1, negative 7.1 plus 0 is equal to negative 7.1. So this is true no matter what number I choose for x. Okay, so that's what an identity is. Let's find some trig identities. Over here, I have a little spreadsheet, and let me tell you how to read this. So in the top row, I have some angle measures. This is what I call x. X is in this spreadsheet, x means the angle that I'm talking about, okay? So when the angle is 0 degrees, for example, then the sine would be 0 because the sine of 0 degrees is 0. If x is 180, then the sine of 180 degrees is, again, 0. The cosine of 180 degrees is negative 1. The tangent of 180 degrees is 0 because 0 divided by negative 1 is 0. Okay, if I were to pick 315 degrees, the sine of 315 degrees, where would 315 degrees be, by the way? That would be if I went all the way around over to here, that's 315 degrees. Then the sine would, which is the y coordinate of this point over here, would be about negative 0.71. The x value, so the cosine of 315 degrees would be about positive 0.71. And the tangent would be this divided by this, which would give us negative 1, because these have the same absolute value, but one is negative and one is positive. So when we divide them, we would get negative 1. Okay, so that's how to read this spreadsheet over here. We have the angles in the top row over here, and then just what the sine and the cosine and the tangent of those angles would be. I did it from 0 up to 360, but you could go even further than that, right? You can just keep spinning this around and around and around. Now, I have another row over here, and I'm gonna change this as we go through the video. I'm going to change what's down here. Right now, I put the opposite of x. So it's the opposite of whatever angle I put in the top row over here. So the opposite of 0 is still 0. The opposite of 45 is negative 45. The opposite of 90 is negative 90. The opposite of 135 is negative 135. So whatever I have over here, I have the opposite over here. And then we're trying to find the sine and the cosine and the tangent of the opposite of whatever is in this row. So we're finding the sine and the cosine of the tangent of these numbers, which are the opposite of these numbers, okay? All right, now let's see if we can find any kind of relationship between the sine of x and the sine of the opposite of x, and the cosine of x and the cosine of the opposite of x, okay? Let's take a look at the sine of x first and compare that to the sine of the opposite of x. So the sine of 0 is 0, okay? And the sine of the opposite of 0, which is still 0, is 0 again. All right, the sine of 45 degrees is about 0.71. The sine of negative 45 degrees is about negative 0.71. The sine of 90 degrees is 1. The sine of negative 90 degrees is negative 1. The sine of 135 degrees is about 0.71. The sine of negative 135 degrees is about negative 0.71. Okay, so it looks like we keep getting the opposites here. All right, the opposite of 0 is 0, so that's still the opposite. the opposite of 0.71 is negative 0.71. The opposite of 1 is negative 1. Okay, and you can see that we just keep getting the opposites. When we took the sine of x, we got some number. And then when we took the sine of the opposite of x, then we got whatever the opposite of this number was. So over here, the sine of 225 degrees is negative 0.71. But the sine of negative 225 degrees is positive 0.71. So these numbers over here, which were negative up here when we were taking the sine of x, now down here they're positive. Okay, so everything is getting changed from either negative to positive or positive to negative. In the case of 0, 0 is neither negative or positive. So the opposite of 0 is still just 0. So it looks like when we're taking the opposite argument, by the way, the value that we put in the parentheses over here, which is the angle, a fancy word for that is argument. So you're going to hear me use the word argument sometimes when I'm just talking about the angle that's inside here. All right, so how could we write the relationship that we just found? That if we take the opposite argument, then we get the opposite value out. Here's the way that we're going to write that. We can write that the sine of the opposite of whatever x is equal to the opposite of the sine of x. Let's do an example. Let's say I wanted to know what the sine of negative 45 degrees is. Well, I know that the sine of negative 45 degrees should be equal to the opposite of the sine of 45 degrees. So that's equal to the opposite of, well, what's the sine of 45 degrees? The sine of 45 degrees is about 0.71. So this is the opposite of 0.71, which is negative 0.71. And we could have started with a positive number in here as the argument as well, okay? And then this rule would still be applicable. So, for example, the sine of 45 degrees, well, we already know that the sine of 45 degrees is about 0.71, but let's, just as an example, let's use this rule over here. Just because there's a negative symbol in here, it doesn't mean that what's in here is necessarily a negative number. It just means that this and this are opposites. So if this is negative, then this is positive. If this is positive, then this is negative. So this is positive. So it's like I have a positive number over here. Then that's going to be equal to the opposite of the sine of the opposite of that positive number. So it would be, so in here, I'm going to put a negative number. All right, so I'm going to write that the sine of 45 degrees is equal to the opposite of the sine of negative 45 degrees. And we already figured out before that the sine of negative 45 degrees is negative 0.71. So now we have the opposite of negative 0.71, which is positive 0.71. Okay, which we already knew, so that was just an example to show you that this works even if we put a positive number in here to begin with. All right, so that's one identity. Let's see if we can find any more identities. Let's check out the cosine now. So the cosine of 45 degrees is about 0.71, which happens to be the same as the sine of 45 degrees. All right, the cosine of negative 45 degrees. So if x is 45, then the opposite of x would be negative 45. The cosine of negative 45 degrees is, again, positive 0.71. So it was positive here, and it's still positive here. All right, the cosine, let's go back here. The cosine of 0 degrees is 1. The cosine of the opposite of 0 degrees, which is still 0 degrees, is still 1. Okay, so of course it would still be 1 because we're putting the same number in. It was 0 here, it's still 0. All right, so let's move on over here. The cosine of 90 degrees is 0. The cosine of negative 90 degrees is still 0. The cosine of 135 degrees is negative 0.71. The cosine of negative 135 degrees is still negative 0.71. The cosine of 180 degrees is negative 1. The cosine of negative 180 degrees is still negative 1. So it looks like we keep getting the same answers no matter what. Okay, for the cosine of x and the cosine of the opposite of x. So another identity that we can write, this time for cosine, is that the cosine of the opposite of x is equal to the cosine of x. They're the same. So, for example, if I wanted to figure out what the cosine of negative 45 degrees was, then that would be the same as the cosine of 45 degrees. So if I knew what the cosine of 45 degrees was, then I could easily figure out what the cosine of negative 45 degrees is, because they would be the same, all right? And the cosine of 45 degrees is about 0.71. Okay, so the cosine of negative 45 degrees is also about 0.71. Okay, so now let's take a look at tangent. We have 0 here, 0 here. 1 here, negative 1 here. We have this, which Microsoft Excel is giving me this error message telling me that I can't divide by 0, right? Because to find the tangent, we would take the sine and divide it by the cosine, but you can't divide by 0. So that's why I'm getting this message. I'm getting the same message over here. Over here, I have negative 1. Over here, I have 1. Here's 0 and 0. Here, 1 and negative 1. All right, so it looks like I'm always getting the opposite again. Negative 1 is the opposite of 1. 1 is the opposite of negative 1. 0 is its own opposite. 0 is the opposite of 0. You can see over here, like I said, we're getting an error message here. Excel is telling us not to divide by 0. But if you remember from the last video, as we move closer and closer, so if we go from 0 to 45 and then get closer and closer to 90 degrees, we would be approaching positive infinity. Okay, at 90 degrees exactly, sine is positive 1, cosine is 0. But over here, you can see that if we take the opposite argument, we would actually be approaching negative infinity as we continue to divide the y values by the x values. All right, so here, this way we're approaching positive infinity. This way we're approaching negative infinity. So we are always getting the opposites for the tangent as well. So another identity that we have is that the tangent of the opposite of x, where x is just some angle. When I say x here, I'm not talking about the x value of where the line meets the circle. I'm using x as my variable to represent the angle. So the tangent of the opposite of some angle is the same as the opposite of the tangent of the angle. So that's like what we had for sine earlier. Now we just found all of these identities by picking some angle measures and then looking at what the sine and the cosine and the tangent were for those angle measures, and then looking at what the sine and the cosine and the tangent were for the opposite of those angle measures, and just seeing if there were any patterns. But I'd like to explain to you a more intuitive way of figuring out why these identities are true by looking at the circle over here. So we'll do it for sine and cosine, and then tangent will follow just from the definition of what tangent is, as the sine divided by the cosine. So let's say that this red line is going to follow whatever x is doing over here. So if x says that I want you to be at 0 degrees, then this red line is going to be at 0 degrees. If x says I want you to be at 45 degrees, then he's going to go up to 45 degrees, right? If x wants to be at 135 degrees, then this will go over to 135 degrees. Okay, so this red line is very obedient. It follows whatever x says to do. This green line over here this green line over here is sort of a troublemaker. It does the opposite of whatever the instructions are. So if x says, hey, I want you to go to 45 degrees, the red line is going to comply, and the red line will go up to 45 degrees. But the green line is going to say, no, I'm going to do the opposite of whatever you're telling me to do. You can't tell me what to do. So the green line is going to go to negative 45 degrees. Okay, if x said, even though I don't have it over here, if x said go to 60 degrees, let's say, then the red line would go to 60 degrees, but the green line is going to go to negative 60 degrees. So the green over here is doing the opposite of whatever the red is doing. Okay, it's going clockwise by the same amount that the red line is going counterclockwise. All right? Now, what's the result of that? What's the result of that for sine? And what's the result of that for cosine? So remember, let's look at sine first. Remember, the sine is just what the y value is. Okay? And I'm going to go back to my flashlight analogy. I'm going to draw my flashlight over here. It's going to shine a light over here. Okay, and then we can see that the shade, let's say we're at 60 degrees, the shade for the red line is going to be over here. The shade for the green line is going to be exactly the same length. It's going to be just as long as for the red line, but it's going to be down here. So if the y value for the red line of where the line meets the circle is positive, then for the green line it's going to be negative, right? And let's say that the red line went all the way down to here, and then the green line did the same thing but in the opposite way. Okay, so let's say about that. Now I have to move my flashlight over. So now let's put the flashlight over here, but it's the same idea. Okay, the shadow for the red line is going to look like that. The shadow for the green line is going to look like that. Okay, these are the y values. You can see that the y values have the same absolute value, but they're opposites of each other. So the length is the same, but the green line now is in positive territory, and the red line, the shadow for the red line, is in negative territory. Okay, so that's why if the green line is doing the opposite of whatever the red line is doing, then the shadow over here is going to be the opposite of whatever we got as the shadow for the red line. Okay, so that's basically what this identity over here is saying. Now for the cosine, remember for the cosine, we're looking at the shadow along the x-axis, right? The x value of the point where the line meets the circle. I'm just using the shadow analogy, but we're really just talking about the x value of the point where the line meets the circle. So if I change my flashlight now, and now I have my flashlights pointed like this. All right, now look at the shadow. Look at the shadow for the red line. The shadow for the red line would look like this. The shadow for the green line would also look like this. It would be exactly the same. Okay? If the red line was over, I don't know, let's say over here, then the green line does the opposite and it goes over here, then what would the shadows look like? The shadow for the green line would look like this. The shadow for the red line would also look like this, okay? Exactly the same. So even if the green line is doing the opposite of what the red line is doing, the x values of these points over here are going to be the same, okay? And that's why the cosine of the opposite of some angle is the same as the cosine of that angle, okay? So hopefully that makes it seem a little bit more reasonable of where these identities came from. Now, what about the tangent? Well, the tangent of the opposite of x, by definition, the tangent of the opposite of x would be the sine of the opposite of x divided by the cosine of the opposite of x. That's just by the definition of what tangent is. It's the opposite of the sine divided by the cosine, okay? So if I'm taking the tangent of some angle, then it would be the sine of that angle divided by the cosine of that angle, okay? But we already learned from these identities that the sine of the opposite of x is equal to the opposite of the sine of x. And the cosine of the opposite of x is exactly equal to the cosine of x. Okay, and we could write this another way. Instead of saying that the numerator is negative and then divided by a positive denominator, we could just bring that negative in front. This is the same thing as saying negative sine of x over cosine of x. But what is sine of x divided by cosine of x? By definition, that's just the tangent of x. So this whole thing means the opposite of the tangent of x. Okay, so if we know that these two identities are true, then we can figure out that this identity must be true, that the tangent of the opposite of x must be the same as the opposite of the tangent of x. All right, so we saw what happened when the argument is the opposite of x. Now let's make this green line here misbehave in a different way. So it's like Bart Simpson, and it's got all kinds of ways of getting into trouble. Let's see what happens if it says, you know what, instead of doing the opposite of whatever the red line is doing, it's gonna go as far as the red line went and then go even further by 180 degrees. Okay, so whatever this is, we're gonna add 180 degrees to it. All right, so if x is 0, then x plus 180 is 180. If x is 45, then x plus 180 would be 225, because 45 plus 180 is 225, and so on. So these numbers are just these numbers plus 180. Okay, so if x is 45, then over here we're taking the sine of 45 degrees, which is about 0.71. But over here, we're taking the sine of 225 degrees, which is about negative 0.71. All right, let's see if we notice any patterns going on here. So here, let's look at the signs first. Here we have 0, 0, 0.71, negative 0.71, 1, negative 1. 0.71, negative 0.71. It looks like whatever is happening over here, we're getting the opposite down here, right? And we already talked about how the opposite of 0 is still 0. So these we can think of as being opposites, even though it's the same number. So it looks like we got our first identity pretty easily here. We can write that the sine of x plus 180 is equal to the opposite of the sine of x. All right, let's take a look at cosine now. What's happening with cosine? Here we have 1, here we have negative 1. Here we have 0.71, negative 0.71. 0, 0, okay, those are still opposites. Negative 0.71, positive 0.71. So it looks like for cosine also, we're getting the opposite down here of whatever we had up here. Okay, whereas before the cosine of the opposite of x was the same as the cosine of x, now we're finding the cosine of x plus 180 is the opposite of the cosine of x. So another identity that we can write is that the cosine of x plus 180 degrees is equal to the opposite of the cosine of x. All right? Now, what is happening with the tangent? Here we have 0, 0, 1, 1. Here we have that we're getting an error message both times. Here we're getting negative 1, negative 1, 0, 0, 1, 1, 1. So it looks like for the tangent, we are getting the same value both times. So the tangent of x, whoops, I'm getting very lazy. T-A-N. Okay, the tangent of x plus 180 is equal to the tangent of x. Now you might be a little bit confused because earlier in the video we had this same error message here and here, but I told you that these were opposites because this was, one of them was positive and one of them was negative. And it looks like we have the same kind of thing over here where this is positive and this is negative. So why am I saying that these are the same? Well, you have to imagine approaching 90 degrees from, let's say we start at 45 degrees and we approach 90 degrees. Here, this was positive, so we're going from a positive 0.7 to a positive 1. So everything is positive from 0.7 to 1. Everything is negative from negative 0.7 to negative 1. Here, going from here to here, everything is still positive as we go from positive 0.71 down to 0. Everything is still positive, right? 0.7, 0.6, 0.5. Everything would still be positive as we go down to 0. Over here, if we're starting at negative 0.71 and then going up to 0, we would have negative 0.7, negative 0.6, negative 0.5, negative 0.4, and so on until we get to 0. So all the numbers between here and here are negative, and the numbers between here and here are also negative. Meanwhile, all the numbers between here and here are positive, and all the numbers between here and here are also positive. So remember, we can't actually divide by 0, but what we can do is think about what's happening as we approach 90 degrees. And as we approach 90 degrees, over here, we would be dividing positive numbers by positive numbers. Over here, we would be dividing negative numbers by negative numbers. Now, a positive divided by a positive is still positive. A negative divided by a negative is also positive. So even though we got an error message here, we can see that they're approaching the same value. So we will not consider these to be opposites. As we go towards 90 degrees, both the tangent of x and the tangent of x plus 180 they're both approaching positive infinity. Okay, so everything, the tangent of x and the tangent of x plus 180 is always the same. So that's where we get that identity here. So once again, we found these identities by seeing if there were any patterns in this spreadsheet over here. But let's go over to the circle and see if we can get a more intuitive sense of why these identities are true. Okay, so we're going to look at the circle for the sine and cosine functions, and then once we have those, then we can figure out the tangent function. So remember, the green line is misbehaving. Whatever the red line does, the green line is going to go 180 degrees past it. So if the red line is over here, then the green line is going to go 180 degrees past that, and it would end up over here. Okay, because this would be a straight angle here, 180 degrees. So these two, they're sort of back to back, making a straight line now. And now let's go back to our flashlights over here. I'm going to put, for the sine, I'm going to put the flashlights this way. And we'll see where the shadows are along the y-axis. For the red line, the shadow is like this. For the green line, the shadow is like this. These are the shadows that are along the y-axis, because remember, when we talk about sine, we're talking about the y values, okay? So they are the same length, but one is in positive territory and one is in negative territory. Now, what if we move, let's say that red wants to go all the way over here, and then green would go here and then go 180 degrees even further. So green would end up over here. And now let's shine the flashlights and see where the shadows are along the y-axis. Once again, the shadows are the same length, but one is in positive territory and one is in negative territory. Okay, so hopefully this identity makes sense after seeing that the sine of x plus 180, which is represented by the green line over here, is always the opposite of the sine of x, which is represented by the red line. Or really, I should say the shadow of the red line, and this is represented by the shadow of the green line. All right. Now, we still have, for these identities over here, the green line is still going 180 degrees past whatever the red line is doing. But now we're talking about the shadows along the x-axis when we talk about cosine. So let's move the flashlights so that they're shining either straight down or straight up. And then where would the shadows be? So the shadow for the red line is going to be here. The shadow for the green line is going to be here. Okay, once again, we see that the shadows are the same length, but one is positive and one is negative. And no matter where the red line is, if the green line is 180 degrees past the red line, then the shadows are still going to be the same length, but opposite directions. So one is positive and one is negative. So if we know what the cosine of x is, then the cosine of x plus 180 would be the opposite of that. Okay? So now that we've figured that out, let me just erase this so I can see both functions. Now that we've figured that out, let's see if we can figure out where this identity comes from. So we saw it from the spreadsheet, but could we also figure it out knowing what these identities are? Well, yes, we could. We could say, okay, I want to know what the tangent of x plus 180 is. So how am I going to do that? Well, I'm going to go back to the definition of what tangent is, which is just the y value divided by the x value, right? Or sine divided by cosine. So the tangent of x plus 180 is equal to the sine of x plus 180 plus the cosine. Sorry, over the cosine of x plus 180. But we know from these identities that the sine of x plus 180 is equal to the opposite of the sine of x. So in the numerator here, I can replace this. I can substitute this in for this. And in the denominator, I can substitute this in place of this. And the opposite of sine divided by the opposite of cosine, these negatives cancel out. And this is the same thing as just the sine of x over the cosine of x. Okay, just like as an example, let's say negative 6 divided by negative 3 is the same thing as positive 6 divided by positive 3, right? Negative 6 divided by negative 3 is positive 2. Positive 6 divided by positive 3 is also positive 2. So this and this are the same, just like this and this are the same. But this is just the definition of what tangent is, the sine divided by the cosine. So this is equal to, by definition, the tangent of x. And so logically, we were able to make a series of substitutions and figure out that the tangent of x plus 180 should be the same as the tangent of x. Now, the last set of identities that we are going to look at are going to involve what happens when the green line goes just 90 degrees past the red line. So we're going to take whatever is over here and add 90 to it. And let's see if we can find any patterns. Let's take a look at sine first. So, oops, how do I keep ending up with yellow? When do I use yellow? Oh, right, when I do that tangent stuff. I usually don't use yellow. Okay, so the sine of x plus 90 is equal to what? Let's see if we can figure it out. So the sine of, here for the sine of x with 0 degrees, the sine of 0 is 0. The sine of 0 plus 90, which is 90, so the sine of 90 degrees is 1. Here we have 0.71 and here 0.71. So here these were the same. Here we got 0 and here we got 1. So these are not the same. They're not opposites either. Here we're getting 1, here we're getting 0. Here we're getting opposites, actually. So this was positive 0.71, this is negative 0.71, as opposed to back here where we got the same value. Here we're getting 0 and negative 1. So it really doesn't look like there's any simple pattern that we could write down, any simple relationship that we could write down between the sine of x plus 90 and the sine of x. What about for the cosine of x plus 90? Is there any simple relationship that we can write between the cosine of x plus 90 and the cosine of x? So here, let's see, 1, 0, 0.71, negative 0.71, 0, negative 1. Are you seeing any pattern here? Because I'm not seeing a pattern. doesn't look like there's any simple relationship that we can write down between the cosine of x plus 90 and the cosine either. Okay, so we're 0 for 2 here. That's where we have 2 strikes. Let's see if we're going to strike out. How about tangent? Are we going to have any better luck with tangent? Here we get 0, here we're getting an error. Here 1, negative 1. Here we're getting an error, here we're getting 0. Negative 1, 1. So it looks like there might be some kind of a more simple pattern between the tangent of x plus 90 and the tangent of x. Maybe looking at it the first time, though, it's still not obvious what that is. So what we're going to have to do here is we're going to have to get a little bit more creative. Over here, when we were looking at the sine of x plus 90, we compared that to the sine of x. Well, we don't necessarily have to compare it to the sine of x. We could see if there's a relationship between the sine of x plus 90 and, let's say, the cosine of x. If there's a relationship between those two, fine, we can write it down. So let's see if there is a relationship. Let's see. Here I have 1, here I have 1. Looks promising. 0.1, 0.71. 0, 0. Negative 0.71, negative 0.71. So it looks like that I'm getting the same answer for the sine of x plus 90 that we get for the cosine of x. So we could write that. It doesn't have to be sine and sine on both sides. As long as there's some relationship, which we see, we can write it down. We can describe it. So the relationship that we see here is that the sine of x plus 90 is always equal to the cosine of x. Let's compare the cosine of x plus 90 to the sine of x. 0, 0. 0.71, negative 0.71. 1, negative 1. It looks like we're always getting the opposite. Remember, 0 is the same as 0, and 0 is also the opposite of 0. So when we were doing this identity, and we had a 0 here and a 0 here, we counted those as being the same. Now that we're doing this other identity, and we see that everything here is opposites, we can also, so we see that everything here between these two are opposites, then we can also count 0 and 0 as being opposites. So it looks like the cosine of x plus 90 is equal to the opposite of the sine of x. So for example, for this one over here, for 225 degrees, the sine of 225 degrees is negative 0.71. The cosine of 315 degrees, which is 225 plus 90, is positive 0.71. So for the cosine of 90 degrees more than this, we get the opposite as the sine of this. So if you have to rewind and listen to me say that sentence a few more times, that's okay. It was complicated. But anyway, here's the identity that we're going to write. Okay, and I'm going to leave this one blank for just a little while. Let's go back over to the circle and see if we can intuitively understand why these identities are true. So how is the green line misbehaving this time? Now the green line says, whatever the red line does, I'm going to go 90 degrees past it. Okay, so let's say that the red line was over here. The green line is going to catch up to the red line and then pass it by 90 degrees. Okay, so we can see that there is now a right angle between the red line and the green line. Okay, now let's go ahead and shine our flashlights and see what's going on. I have also gone ahead and color-coded this picture over here. So I put the flashlights in different colors. So whenever I shine the flashlight in order to find the the sign of something, which is the y value, then I'm going to draw that in blue. Whenever I shine a flashlight and try to find the x value, so the shadow along the x-axis, I'm going to draw that in black. And whenever I'm talking about the green line, then you can see over here I have drawn this in green, and for the red line I have drawn these in red. All right, so this one is a little bit trickier than the others, but let's see if we can go ahead and do it. So I want to find the sine of x plus 90. So if x is, this is 180 degrees over here, so this would be about, I don't know, let's say 200 degrees. So if x is 200 degrees, then x plus 90 would be 290 degrees. So if the red line is at 200 degrees, then the green line would be at 290 degrees. And now we want to find the sine of 290 degrees and the cosine of 200 degrees and see if they are in fact equal to each other, if they are the same. So to find the sine of something, what we're going to do is we're going to shine these flashlights over here and see the shadow that it makes. We're trying to find the sine of the green line. So I'm going to look at, so this flashlight is shining over here. So we're talking about this shadow right over here, which is the shadow made along the y-axis from this green line over here. And let's see if that's the same as the cosine of x. So now we're talking about this red line over here. But when I talk about cosine, I'm talking about the shadow along the x-axis. So let's take a look at this flashlight over here. And if this flashlight shines a light over this red line over here, then the shadow is going to look like this. Okay, so one thing that you'll notice about these two shadows is that, first of all, they're both the same length. And second of all, both of them are in negative territory. Okay, on the y-axis, this is negative, and on the x-axis, this is negative. So they're both the same length, and they're both negative. And so, yeah, we can see from this picture that the sine of x plus 90 should be the sine of cosine of x, at least in this example. We'll do another example after this, but let's also, while I have this up, let's take a look at this. So now I want the cosine of x plus 90. So I want to find the cosine of this green line, which means I'm going to shine this flashlight on it and find the x value of where this line meets the circle. So this is the length of this would be the x value over here. Okay, so that's for the cosine of x plus 90. And then the sine of x. So let's figure out what the sine of x is by shining one of these lights. And now we're talking about the red line. Let's see. So if we shine this flashlight on here, then the shadow would look like this. Okay, so it does look like these are the same lengths. However, this, which is along the x-axis, is in the positive territory, and this shadow on the y-axis is in negative territory. So one is positive and one is negative, and that's why this negative symbol is over here. And this means that these are opposites of each other. So if one is positive, then the other is negative. If one is negative, then the other is positive. Okay, and that is what we can see from the picture. And I'll just do one more example. You could do a bunch of examples on your own if you're interested, and you should be able to convince yourself that this is true. I'm going to do one more example myself, and then you can play around with it yourself on a piece of paper if you want. Let's move the red line over to, I don't know, let's say over to here. And then the green line would be 90 degrees past that. So the green line would then be over here. And let's see if these identities are correct. So if I want the sine of the green line, that means then we're talking about the y value. So if this shines a light on the green line, then the shadow on the y-axis is going to go up to here. And now for the cosine of x, I'm looking for the shadow on the x-axis of the red line. So now I'm shining this flashlight to find the shadow along here. Okay, and you can see that they are the same length, and both of them this time are in positive territory. Okay, the y shadow, this blue shadow over here is in positive territory. This black shadow over here is in positive territory. And now over here, let's see what happens. Now we want the shadow along the x-axis of the green line. Shadow along the x-axis of the green line. Let's see. So we're going to shine this flashlight over here. It would make this shadow. Now we're going to shine. Now for this one, we want the shadow along the y-axis of the red line. Let's see. So if we shine this flashlight on the red line, then the shadow along the y-axis would look like that. Okay, and maybe I didn't do such a great job of drawing these things, but these should be the same length. But you can see that one of them is in positive territory. That's this one. This is positive for the y-axis. One of them is in negative territory. Okay, so for the x-axis, then to the left is negative, right? So this is in negative territory. This is in positive territory. So again, we see we have validated having this negative symbols here, because we see that even though the lengths are the same, so the absolute values are the same, one of them is positive and one of them is negative. Okay, so we are getting opposites, and that's why that negative symbol is there. Okay, so we've seen that these identities are true. Now let's use these identities to figure out what the tangent of x plus 90 should be. We weren't quite able to find it over here, but it looked like the relationship between this and this. It looked like there was something going on here which shouldn't be too hard to describe, but it's still not totally obvious because we have these error messages here which are telling us that we divided by 0. And that's corresponding to a 0 over here. So what's the meaning of that? So let's go ahead and just do it by the definition of what tangent is. So tangent is sine over cosine. So the tangent of x plus 90 is equal to the sine of x plus 90 divided by the cosine of x plus 90. But we know from here that the sine of x plus 90 is equal to the cosine of x. And we know from here that the cosine of x plus 90 is equal to the opposite of the sine of x. And another way of writing this is negative, or the opposite of cosine of x over the sine of x. Now, this is the reciprocal of what the definition of tangent is. The definition of tangent is sine over cosine. Over here we have cosine over sine. So we can write all of this as negative the reciprocal of tangent, which is 1 over tangent. Okay, just to show you that this makes sense, if we do 1 over tangent, well, the definition of tangent is sine over cosine. So this is like 1 over sine over cosine. I'm just going to leave the x's out for now. And then if I do keep, change, flip, keep this, change division to multiplication, and then flip this, and I get 1 times cosine over sine, which is cosine, which is just cosine over sine. Okay, so 1 over tangent is the same thing as cosine over sine, which is the reciprocal of tangent. There is just a name for this, which you may have remembered from the other video. I ran out of space over here, so I'll just write it over here. The reciprocal of tangent does have its own name. It's called cotangent. So the opposite of the reciprocal of tangent would be the opposite of the cotangent. Okay. But this might be a little bit easier just by thinking of this, which you might not be so familiar with. It's just easier maybe thinking about it in terms of reciprocals. So 1 divided by whatever the tangent is, and then take the opposite. So I wrote that over here, by the way. And let's do an example now. So how can I figure out what the tangent of 135 degrees is if I already know that the tangent, if I already know what the tangent of 45 degrees is? Well, 135 is 45 plus 90. So I could write the tangent of 135 as the tangent of 45 plus 90, because that's what 135 is, 45 plus 90. And now I can go ahead and use this identity over here, and my x is 45. So the tangent of 45 plus 90 is equal to the opposite of 1 over the tangent of just x, which in this case is 45. So if I know that the tangent of 45 is 1, then I can write this as negative 1 over 1. So I'm just substituting 1 in for the tangent of 45. And then 1 divided by 1 is 1. And then so I have negative 1 as my final answer. Okay, now what if, let's try doing the same thing with 270. So the tangent of 270 can be written as the tangent of 180 plus 90. Okay, because 180 plus 90 is just 270. So I'm just writing 270 in a different way as 180 plus 90. This, according to this identity over here, should be equal to the opposite of 1 over the tangent of 180. Now the tangent of 180, we can look that up in this spreadsheet over here, is 0. Okay, so we would get, in this case, the opposite of 1 over 0, but 1 over 0 is undefined. You can't divide by 0, and that's why we're getting this error message over here for the tangent for the tangent of 270 degrees. So I would like to finish this video up by doing a few problems, a few simple problems based on the identities which we've been talking about. So let's say that I gave you a problem like this. Hint, hint, you will see problems like this. No, I want to switch to yellow over here. If the sine of some angle, so I'm putting theta in here just to represent some angle. I'm not going to tell you what the angle is. But if I know that the sine of that angle is whatever, let's say 0.47, what is the sine of the opposite of theta? Well, for that, we could just go over to this identity right over here, which says that the sine of the opposite of some angle is equal to the opposite of the sine of that angle. So if I know that the sine of some angle theta is 0.7, then the sine of the opposite of that angle is equal to the opposite of the sine of that angle. But I already know that this is 0.7, so then I have negative 0.7 over here. Okay, so that wasn't too hard, hopefully. So the answer to this problem would be, oops, and I forgot to make that a question mark. And the answer to this problem would be negative 0.47. What if I did the same kind of problem, but I'm going to switch this from sine to cosine? So if I know that the cosine of some angle is 0.7, then what's the cosine of the opposite of that angle? Well, the cosine of the opposite of an angle is equal to the cosine of that angle. That's according to this rule over here. So if I already know that this is 0.47, then this is also equal to 0.47. Okay, simple enough. If for the tangent, it would be exactly the same as what we just said for the sine. It would be the, you know what? Let's do one more example. We'll do an example with tangent, but I'm going to make this negative in the question. Okay, so if I know that the tangent of some angle is negative 0.47, what's the tangent of the opposite of the angle? Well, the tangent of the opposite of an angle is equal to the opposite of the tangent of the angle. If I know that the tangent of the angle is negative 0.47, then the opposite of negative 0.47 is positive 0.47. We did a problem similar to this earlier in the video. Okay, so that's how we would do that. All right, now over here I wrote another set of identities we talked about. Actually, this was the last set that we talked about. And I might give you a problem like this. Let's say I asked you the sine, make that bigger. The sine of 250 degrees is equal to the cosine of what? Well, let's see. 200, using this rule over here, we can see that this looks very similar to this over here, right? So what do we need to do here? We need to write 250 as some number plus 90. So what number plus 90 is the same as 250? So to answer that, we would do 250 minus 90, which is 160. So we could say that the sine of 250 is that we could write this as the sine of 160 plus 90. Okay, and then using this rule, now we see that our x is 160. So on this side, when we plug 160 in for x, we would just see that it's the cosine of 160. Okay, and you can see that that's true, by the way. I'm going to go over to the calculator again. Let's go over to Desmos. Okay. You don't really have to do this, but just to see that we got the right answer here, the sine of, what did we say, 250 degrees? What is that? That's negative 0.93, blah, blah, blah. What is the cosine of 160 degrees? the exact same, the negative 0.93, blah, blah, blah. Okay, so the sine of 250 degrees is the same as the cosine of 160 degrees. All right, now what if I gave you a problem like this? Let's switch this around here. Oh, no, that's not what I want to switch. Let's keep this the same. But instead of sine being here and cosine being here, I'm going to put the cosine here and the sine here. Okay, we can see that this looks very similar to this identity over here. We're going to start out in the same way. We can write 250 as 160 plus 90. Okay, so whatever number is in here, we would just subtract 90 and then write that number plus 90. Okay, so we're going to write the cosine of 160 plus 90. Okay, we're just writing 250 in a different way here. That is equal to, according to this identity, the opposite of the sine of 160, because in this case our x is 160. Here we just have the opposite of the sine of x. Okay, but I didn't ask you the cosine of 250 is equal to the opposite of the sine of what? The question that I asked you was the cosine of 250 is the same as the sine of what? Not the opposite of the sine of what? Okay, so we need to change this so that we do not have this negative symbol over here. You're probably, I'm going to just guess, since you've been, in middle school up to this point, every time you wanted to get rid of a negative, you would divide both sides by -1, something like that, right? To get the negatives to cancel. That's not what we're doing here. What we could do as our final step in this problem is to use another identity which we learned about. So it might have been a little bit misleading of me to only give you these identities, but I just wanted to point out the fact that we cannot answer this problem using this identity alone because there's no negative symbol over here, but here there is. What we can do is we can remember the other identity which we talked about in this video, and actually it was on the screen just a little while ago. Okay, the only difference is I had this on the left and I had this on the right. But anyway, remember we said that the sine of the opposite of x is equal to the opposite of the sine of x. So over here, I have the opposite of the sine of 160. That should be equal to, that is equal to, the sine of the opposite of 160, or -160. Okay, and of course, so what we have here is, let me write it this way. I wrote this below this. Maybe it would be a little bit easier to understand if I wrote this over here. So here's what we did from beginning to end. Is we said, well, the cosine of 250, another way of writing that is the cosine of 160 plus 90. From this identity, we know that the cosine of 160 plus 90 is the same as the opposite of the sine of 160. And then from this identity, we know that the opposite of the sine of 160 is equal to the sine of the opposite of 160. So the sine of -160 degrees. So this should give us the same answer as this. And let's just verify that. So we have the cosine of 250 and the sine of -160. So the cosine of 250, did we do it? No, we did the other one. So this is the cosine of 250 degrees. That should be the same as the sine of -160 degrees. Okay, and you can see that we did get the same exact answer both times. Actually, there are an infinite number of answers to a problem like this, If you've been watching the videos, then you know we could find another angle measure which would give us the same result simply by adding or subtracting 360 as many times as we want. So, for example, if I take this green line here and I rotate it another 360 degrees, I end up in the same place that I started. So I would get the same answers for the sine and the cosine and the tangent of whatever this angle is. If I rotate by 360 degrees again, I end up in the same place again. I could also go backwards by 360 degrees. So if I take negative 160 and I add 360 to it, and then take the sine of that number, I should get the same answer. So negative 160 plus 360 is positive 200. So I should get the same answer by putting in the sine of positive 200, and you can see that I do. I can add another 360, then I would be at 560, and you can see that we get the same answer again. Or I could have started here and gone and subtracted 360. So negative 160 minus 360 would be negative 520, right? I hope I did that right. Otherwise, I'm going to be embarrassed. Negative 520. I'm not embarrassed. Okay, good. So there are an infinite number of solutions because remember the question was the cosine of 250 is the same as the sine of what? Well, you could say that the cosine of 250 degrees is the same as the sine of negative 160, or you could say it's the same as the sine of 200, or you could say it's the same as the sine of 560, and so on and so forth. So there are an infinite number of answers, but in the problems that I'm going to give you, I just want you to give me the answer that you would get by following the method that I just explained. Okay, so for that kind of a problem, and I'm going to do another very similar example now. Okay, last question of the video. The tangent of 219 degrees is equal to the tangent of what? So this looks like a pretty silly question. Shouldn't the answer just be 219? The tangent of 219 is the same as the tangent of 219, right? Well, yes, of course. That's one possible answer. There are, like we said a minute ago, there are an infinite number of possible answers that would work. The answer, if I give you a problem like this, the answer that I want you to give me is the answer that you would get by just using this identity, okay? So this is the identity that we're going to use this time. So we're going to say that we're going to write 219 in a different way first. So 219 is the same as, what's 219 minus 180? That would be 39. So the tangent of 219 is the same as the tangent of 39 plus 180, because 39 plus 180 is just 219. Okay, it's just another way of writing 219. But now we can go ahead and use this identity and say that the tangent of 39 plus 180 is the same thing as the tangent of 39. Okay, so the tangent of 219 degrees should give us the same thing as the tangent of 39 degrees. I'm not writing the degree symbol over and over again, but these are all in degrees. And let's just verify that in the calculator. That we have 219 and 39, right, for tangent. So the tangent of 219 is what? You get 0.80 blah, blah, blah. The tangent of 39 degrees is 0.80 blah, blah, blah. Okay, same exact answer. So good, it worked. I am going to end the video there and have a great day.